Welcome student. Today I am going to teach you predicate calculus. I am Varun Kumar, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Now we are going to discuss the predicate calculus. There is some fundamental which we have to learn before we start predicate calculus, that is the logic and propositional logic functions. What is the logic? Crucial for the mathematical reasoning, that important for program designing and used for the designing electronic circuitry and etc. etc. A statement which has the declarative values either true or false is known as proposition. So a proposition is a declarative statement that is either true or false, not both at the same time. We say that truth value of the proposition is either true or false. Corresponding to 1 and 0 for digital circuit, as we discussed in the previous lecture number 3, Boolean algebra, we discussed the all things are in terms of 1 and zeros. The statement elephant are bigger than mice. Is this a statement? Yes, this is a statement. Is this is a proposition? Elephants are bigger than mice. The condition is true, so it is a proposition. So what is the truth value? That is the true. So we take one more example, that 520 is less than 111. So is this is a statement? Yes. Is this is a proposition? Yes. What is the truth value? That is the false. It not means that the proposition always contain the value truth. So same example is there, 2 plus 4 is equal to 6. Truth value is true. 5 and 6 is a proper set of 5, 6 and 7, as we observed that this is also a proposition. What is the truth value? That is the true. And if y is greater than 5, is this is a statement? Yes, y is greater than 5. But at same time, what is the value of y? We don't know the value of y. For some value of y it is true and some values it is false. So we cannot define this particular statement is true or false. So this is not a proposition. So next proposition is, today is January 27 and 99 is less than 5. So we can combine the two statements together. Is this is a statement? Yes. Is this is a proposition? Yes. What is the truth value of this? That is false. 99 can't less than 5. So condition is false. So please do not fall asleep. This is a statement? No. It is a request. A request can't be a proposition because we cannot define this particular request into the true and false. Next statement is, please report at 11 a.m. sharp. Is this is a statement? No. It is a order. So this is a proposition? No, because it not possess any truth values, that is true or false. So similarly, do you speak Hindi? And if the moon is made of cheese, then I will be a rich. This is a statement? Yes. Is this is a proposition? Yes, it is a proposition, probably true. If x less than y, if and only if y greater than x, so this is statement? Yes. If this is a proposition? Yes. Or because its truth value does not depend upon the specific value of x and y, if x is less than y, so it means that y is greater than x. So truth value is always true. So combining proposition, as we see in the previous example, one or more proposition can be combined to form a single compound proposition. So we formalize this denotation of proposition with the letters such as P, Q, R, S, and we use several connectivities which are known as logical connectivities or propositional logic. Sometimes we are using that note. Note is symbolic representation, either this or this. Conjunction use behave like a AND gate, and we use the logical connectivity. And disjunction behave like a OR gate, and exclusive or implication, if P then Q. If first statement is true, then second statement also true if P then Q. By condition if and only if. Negation, it is a unary operator. The truth, we can check the truth table of the negation, that if true then output is false, then output is true. Negate the following statements, that today is Tuesday. The negation of this statement is today is not a Tuesday. No one wants to buy my house, then negation of this is someone wants to buy my house. And 5 plus 1 is equal to 6. This is a statement because we can declare this values into the true and false. The statement, given statement is true. So what is the negation of this statement is 5 plus 1 not equal to 6. Some people have no bikes. Every person has a bike. And logical connectivity, that is conjunction, which is symbolized with this particular symbol we are using in the predicate calculus. If P is true and Q is true, then output is true. Then true and false, then output is false. Then false and true, output is false. Then false and false, then output is false. It means the conjunction of two or more propositions, or if all propositions are true, then output is true, otherwise false. The first statement is P, that Ram is healthy, and second statement is Q, that is he has blue eyes. So we can conjunct with these two propositions, that P conjunction with Q, which is represented as Ram is healthy and he has a blue eyes. Similarly, first statement is 5x plus 6 is equal to 26, and second statement is x greater than 3. So we can conjunct those proposition, that P conjunction with Q, that is 5x plus 6 is equal to 26 and x greater than 3. So what is the conjunction here? That is the AND. We are using the logical AND operation here. Disjunction, same. True, true, then output is true. True, false, output is true. Then false, true, then output is true. And false, false, output is false. If all propositions are false, then output is false, otherwise true. The first statement is he will go to Delhi, and second statement is he will go to Agra. So we disjunction the two proposition, that is P disjunction with Q, that is he will go to Delhi or Agra. So we are logical connectivity with OR gate. And similarly, P candidate must know English. Then second statement is candidate must know Hindi. So we conjunct two proposition, that P conjunction disjunction with Q, that is candidate must know English or Hindi. Implication, if P then Q, if first statement then second statement. So output is, if true true, then output is true. If true false, then output is false. So we remember that if first proposition is true, then second statement can't be false. Otherwise, in all case, the proposition logic is true. The first statement, I will get the money and I will purchase computer. So P implication with Q is, if I will get money, then I will purchase a computer. Consider the following, that P, tomorrow is Sunday, today is Saturday. If tomorrow is Sunday, then today is Saturday. It rains, first proposition is it rains, I will carry an umbrella. If P then Q, it means P implication Q, the statement is, if it rains, then I will carry an umbrella. By conditional if and only if, it is behave like a XNOR operation, then output is true 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 and false false true. If both proposition is true, then output is true. If both proposition are false, then output is true, otherwise false. Tautologies and contradiction, if any Boolean expression or any propositional function possesses the value all true, then it is known as tautology. And a contradiction is a statement that is always false, like or conjunction with negation of or, it possesses always value false. So that we start with the propositional function. Propositional function or predicates are the proposition that contain the variable like we have studied that x greater than 3, this is not a proposition, but if we make this statement like this, Px where x is greater than 3 and we supply some value to the x like P of 1, then we substitute 1 here, then 1 greater than 3, this particular statement become a proposition. We can define this particular statement as a true or false. At P at value x is equal to 1, this particular proposition possesses the truth value is false. So, Px has no truth value until the variable x is bounded by either assigning it a value by and quantify it. Assignment of values like let q x comma y, it is a particular propositional function with two variables, that is x and y, denoted as x plus y is equal to 7. Each of the following statement can be determined as a true or false like this. Q 4 comma 3, it means x is equal to 4 and y is equal to 3, and we substitute here that 4 plus 3 that equal to 7. This statement is true. And what about Q 3 comma 2, that is 3 comma 2, x is equal to 3 and y is equal to 2. So 3 plus 2 equal to 7. This is also a proposition. This truth value is false. This truth value is true. The next statement is either 4 comma 3 is true or Q 3 comma 2 is true. We know that the sum of these two is 7. So this is true and this is false, and according to the table the output is true. So what is this? Q 4 comma 3 and conjunction with Q 3 comma 2, this possesses the truth value true and this is false. According to conjunction logic, if all input is true, then output is true, otherwise false. So what is the value of this? False. Quantifiers, that is the universe of discover, that is U, the domain of a variable in a propositional function. Universal quantifier of P of x is the propositional that Px is true for all value of x in U. Every value of universal set gives the value returned as a true. Existential quantifier of P of x is a proposition there exists an element, at least one element, that in x such that Px is true. Universal quantifier for all, this symbol is used for the for all, or for each, for all, yeah, every. We can use these synonyms as for all, for each, for every. For every x Px, the value of Px is always true for all value of x. Whatever value the x we have substituted into this particular propositional function, that gives the return the true value. For all x Px, for every x Px, or we can say that ki P x0, x1, x2, x3 and up to all values, and we use the sign conjunction. It means if all conditions are true, then output is true. So for all x of I in U, this particular proposition is true. So this is known as a universal quantifier. For example, P of x denote as x square is greater than equal to x if x is in U such that in between 0 to 1, then all P of x is false. If U is x such that 1, x is always greater than 1, the all x for all value of x Px is always true. Existential quantifier, we are using the symbol that this particular symbol is for the existential quantifier. There exists x such that Px की P value of Px is always true for some value of x, for some at least one. There is a at least one x such that Px. There exists at least one x such that Px is true for that particular value of x. Definition, that is P x0, x1, x2, x3 and all, we use disjunction function, and disjunction function tell us that if all input is low, then output is low. If all propositional or logics are false, then output is false, otherwise high. For example, P of x denote x square is greater than x. So if u is in x such that x in between 1 and 0, then there exists some x that Px is true. What is the value of that? Px is equal to 1. If we substitute x is equal to 1 in P of x, that is equal to x square is greater than equal to x, 1 square is greater than equal to 1. So we can say that 1 equal to 1, this particular value is true for x is equal to 1. Quantifier, that true when Px is true for every x. False if there is an x for which Px is false. There exists some x that Px, it means true if there exists an x for which Px is true, or we can say that at least one value of x that Px value is true. False if Px is false for every x. Negation of there exists some x is all false. Negation of existential quantifier is the for all. It means true when Px is false for every x, and false if there is an x for which Px is true. And negation of for all x Px is equivalent to there exists some x negation of Px. It means true if there exists an x for which Px is false, and false if Px is true for every x. Let Ta be denote as a propositional function A trust on B, or let U be the set of all peoples in the world. So everybody trust Bob. So how we convert this particular statement into the logical connectivities, that is the predicate calculus and symbolic representation. That is for all x, we quantify the value of x for all x. It means all peoples of the universal set. X belongs to the universal set, and universal set contains the all peoples of this particular world. So we write this statement as for all x, that is t, and first value is x. So x, it means a representation of x. X trust B, or here B is the Bob. So we write here t x comma Bob. So this is the logical conversion of the particular statement into the logical connectivities. Could also say that for all x belongs to U, that t x comma Bob, that this is the symbolic representation of belongs, that is the membership operation. Bob trust somebody. So you think about this, Bob trust somebody. It means Bob behave like a. So we replace a with the Bob, and we quantify, there is a word that is a somebody, that is behind the B. So we write this, there exists some x, that t Bob comma x. For example, Alice trust herself. It means what is the value of A, that is the Alice, and what is the value of B, that is also Alice. So we can say that t Alice comma Alice. Alice trust nobody. Nobody means nobody. Okay, okay. So for all x, यानी कि it means all value of this particular universal set, it means all people of this particular universal set, that negation of t Alice comma x, Alice not trust anybody. Then Carol trust everyone, trusted by David. So we can write this for all x t David and x, that tends to t Carol comma x. Then everyone trust somebody. Everyone trust somebody. So what is the quantity of A? That is everyone. Everyone, it means for all. Or there is somebody, that is the value of B. Somebody, somebody means there exists some Y. So we write here for all, it means for all, yani it means everyone. There exists some Y, that is somebody, and X comma Y. X trust on Y. And one more example, that is the symbolic representation. There exists, yani कि there exists at least one, it means someone. Y, it means for all, it means everybody. And what we are used here, what is the function our? A trust on B, it means X trust on Y. Or what is the value of X? There exists some X, it means someone. Someone trust everybody. What about this? That is a somebody. This is for all. Then we write this T X comma Y. So we write somebody is trusted by everybody. Bob trusts only allies. Bob trusts only allies. What is the value of A? That is the Bob. And what is the value of B? That is allies. Or we use only. It means if and only if. So we combine that for all. X is equal to allies, then T Bob comma X. So we can say that P be the X is equal to allies and Q is the Bob trust X. So what is the logical connectivity for P? By conditional operator, that is P by conditional Q, that is if and only if. Then true output is true and false output is true, otherwise false. Quantification of two variables, that is for all X, for all Y, that propositional function, that is P X comma Y. Or we can say that for all Y, for all X and P X and Y. True when P X is true for every pair of X and Y. False if there is a pair of X comma Y and which P X comma Y is false. And there exists some X, there exists some Y for P, X and Y, or we can write that some Y and some X, P, X comma Y. It means true if there is a pair of X and Y for which P, X, Y is true, and false if P, X is false for every pair of X and Y. So quantify the two variables, that is this. True when every X is a Y for which P X is true, in case of Y is depend upon the X. False if there is an X such that P X is false for every Y. So we write that for some Y and some X, that P X comma Y. True if there is a Y for which P X Y is true for every X, and that is true for a particular Y regardless of independent of X. False if every Y there is an X for which P X is false. Note that order matter here. So in particular, this is for some Y, some X and P X is true, then for all X and some Y, P X is also true. However, there is for all X there is some X, P X is true. It is not necessary that for some Y and for all X this particular propositional function is true. Let some example, that let X comma Y be the statement that X loves Y, where U is the both X and Y is the set of all people in the world. Everybody loves Jerry. It means everybody is quantify the value of X and Jerry is quantify the value of Y. So we can write this for all X, L X comma Jerry. So we fix the value of y, that is Jerry. This is a constant value. So everybody loves somebody. So we write this everybody and somebody, then Lx comma y. There is somebody whom everybody loves. It means somebody and for all, that Lx comma y. There is somebody whom Linda does not love. So we can write this statement. Nobody loves everybody. That simple statement is that everybody and somebody. And there is somebody, one or more, whom nobody loves. So we can write this statement with negation sign. Let Px be the statement x is a AKG student and Qx be the statement that is x is ignorant. Then Rx is a statement that x we are read, and universal set is a set of all peoples. No AKG student are ignorant. So we think the propositional logics and we can connect them through the logical connectivity. So we can write that for all x, Px, then negation of Qx. Or we can write that we know that these are the logical equivalent. So we can write that for all x, negation of Px, then conjunction with Q of x. No AKG student are ignorant. So we can write that for all x, Px, then negation of Q of x. So we can write that negation of for all is the negation of there exists some x, Px, then Qx. So we can use the negation equivalent. So we can write this. Then we can use the implication rule. Then after that, De Morgan's law. So we can write this. So we know that double negation is always equivalent to the propositional. So we can say that only true if everyone is the AKG student and is not ignorant. Let one more example that Px same operations are performed, that x is a AKG student, x is ignorant, x is we are read, and no AKG student are ignorant. So we can write this. No AKG student, फिर again all ignorant people we are read. We think about this and we convert it into the logical connectivities, that for all x, Qx, then Rx. What is the Qx? Qx is x is ignorant. What is Rx? That is x we are read. So we can connect them through the logical connectivities. Then last example, that is no AKG student we are read. That for all x, that Px which x is a student of AKG, then negation of Rx. What is the Rx? Rx is x we are read, negation of this is x not we are read. So no AKG student we are read, it means for all x, Px, then negation of Rx. Okay, thank you.